Alright, so we are given a question about a cyclist going down a hill. Let's write out the information that we're given. So first, let's draw a diagram. So let's do a little bit better job. There's a hill with this angle. Let's label that theta. This angle we know is 4 degrees. And there's a cyclist on this hill, and we know that the mass of the cyclist, plus his bicycle of course, is 85 kilometers. And we also know that he starts off at the top of the hill from rest, so 0 meters per second. And the last thing we are given is the distance of 180 meters. Now, there's two parts to this question. The first part is asking us to calculate the net work done by gravity on the cyclist. Now, to calculate the net work done by gravity on the cyclist, all you have to do is simply mass times gravity times the distance, and you have to account for the angle at which the work is done. So it's gravity, which is an angle of 90. It goes straight down. We are all attracted straight down by the force of gravity. So it's 90. And angle theta, which is 4 degrees, we are given that. The angle here, theta, is 4 degrees on the hill. Now we have our equation. All we have to do is plug in the values and solve. So if you plug in 85 for mass, 180 for distance, 9.8 for gravity, which is a constant, and then multiply all that by the cosine of 90 minus 4, which is 86. Let's just write that out. So 85 times 9.8 times 180 times cosine 86. This should give you approximately 1.0 times 10 to the 4 joules. After accounting for sig digs and all, it rounds to 1.0. Now, part B is asking you to solve for final velocity. So we know that work is equal to the change in kinetic energy. Now we also know that kinetic energy is equal to half mv squared. But don't forget about the delta symbol, so change in kinetic energy. So we know that work is equal to 1.0. The work from gravity is equal to 1.0 times 10 to the 4 joules, which is equal to the change in kinetic energy, which is half m velocity final squared minus half mass times velocity initial squared. However, if we look back at the information that we're given, we see that velocity initial is 0 meters per second because the cyclist starts at rest. So that makes all this equal to 0. So what we're left with is 1.0 times 10 to the 4 joules is equal to half mvf squared. Now we know what mass is, so let's just write that in. It's 85 kilograms times Vf squared. Now all we have to do is rearrange. So let's clear up some space here. Or let's just move over here. So what we have to do, we have to isolate Vf. So there's a square. So we know that means we have to square root. But first, before we do that, we have this 1/2. So we have to multiply by 2 to get rid of that. And then we have the 85. So we have to divide by 85 to get rid of that. And then finally, we have to square root everything to get rid of the square to get rid of the exponent of 2 on VF. So we can say that VF equals 1.0 times 10 to the 4 times 2 divided by 85. Now this gives you approximately 16 meters per second after you plug that into your calculator. So we have the net work done by gravity is 1.0 times 10 to the 4 joules, and the final velocity of the cyclist is approximately 16 meters per second. Now some tips for solving similar questions to these. So as you can see, the first thing we did was write out the information that we were given. We also drew a diagram to help us out. And lastly, it comes down essentially to the equations in which we plug in our values. So the equation for work done by gravity, and then the equation for how work is equal to the change in kinetic energy. So basically those are the three main steps: finding the information that you're given, drawing a diagram if necessary, and most importantly, arguably most importantly, finding the equations to plug your values into to figure out what you need to solve for.